Hi, in this video, I will show you how to create a self-hosted GitHub Action runner on Azure Linux VM. In this video, we will focus on how we need to set up our own private GitHub repository. In that one, how we can create the private or self-hosted GitHub Action runners, and we will use that self-hosted GitHub Action runners and try to run the GitHub Action workflows with using this self-hosted GitHub Action runner. So this video is fully end-to-end demo for how you need to set up that machine, that is Azure Linux virtual machine, so that it can act as a GitHub Action runner. And then we use that GitHub Action runner and try to run an example GitHub Action workflow. So that is the aim of this particular video. As part of the demo, I have one private repository called Cloud Cost Optimize. So this is my private repository. So in this repository, what we do is we're going to create a self-hosted runner by going to the settings and then go to the actions here and click on runners. So as of now, I don't have any runners. So what I do is, I'm going to click on a top right hand side. There is a button called new self-hosted runner. Click on that, and then here we're going to choose a self-hosted runner on Linux. Architecture would be x64, and then of course, so automatically the GitHub Actions will give you the step that you need to follow to enable a machine act as a GitHub runner, right? So here we are using Azure Linux VM. So these are all the steps we need to run on that VM, so that becomes the self-hosted GitHub Action runner here. So with this setup in the one side, I'm going to take you to the my Azure subscription. So this is my Azure portal. In this portal, I have a subscriptions. So within that subscriptions, I'm going to create a Red Hat Linux virtual machine. And then, on that virtual machine, I'm going to come back and try to show you that and how we need to install or basically run these configurations so that machine starts reporting to the my GitHub repository, which is private repository, and we can leverage that machine as a self-hosted runner. Now I'm creating an example Red Hat Linux virtual machine with a certain configuration, as you see here. So we are using the this is my name of machine. All these are the options that I have selected. As you see, this is Red Hat Linux 9.4 LVM version cross 64 architecture. And then this is the the size. Remember that we need to use minimum 4 GB or greater than 4 GB. I'm suggesting you to use 8 GB machine for if you are for the GitHub Action runner. If the workflow is very compute intensive or memory intensive, you need to use the size of the VM accordingly, right? And then I'm just going to create a machine here with this configuration. And also one more note, that we're going to make this machine publicly accessible by using a public IP address here. So as you see here, right now we are selecting the public IP address. We are attaching the public IP address because I want to access this machine over the SSH and then run those installation command. That is the reason I'm using public IP address. But for the enabling the machine as GitHub Action runner, it should be okay with the the NAT gateway. So you can use the NAT gateway here, and it should be working, which also I'm going to show you in a couple of minute here. Now you see that our machine is in running state, and it has a public IP address, by the way. So as I said, the assigning the public IP address to a virtual machine is risky. But just to make this machine configured with the GitHub Action runner, so I'm enabling it with the public IP address. Once the configuration is done, I'm going to disassociate from the machine. Okay. So for now, what I do is, as I said, let's try to keep the NAT gateway in front of the machine so that it can talk to the internet through the NAT gateway. So for that case, I'm going to go to the NAT gateway page option, and we're going to create an instance of NAT gateway here. And then we'll also create a route table, and we assign these NAT gateway and route table to the subnet where our virtual machine is sitting, and then we enable a route. Okay, so for now, let me try to create the NAT gateway and route table and come back to you. Okay, so while I create the NAT gateway, I can show you that how I am associating this NAT with the VNet and a subnet within it. So this is the virtual network, where my machine is sitting on a subnet. This is the subnet. Okay, so if I go back to the configuration, right? So when you create a NAT gateway, you can, in that configuration itself, you can map it to a virtual network and to a subnet. right? And then automatically, it will automatically map to that. So basically, this is how we are actually mapping this NAT gateway to a subnet here. Now I'm creating a route table as you see here. Go to the main search and click on a route table and click on a create route table. So here we're going to choose the RG, which is basically the same RG where my machine is sitting. And then the region is basically, the Southeast Asia. So that is, so it's the same, it should be the same region where your machine is sitting. So you can go back and check it again. So if I discard all these setup and show you that, our machine is sitting here, or you can check it from the resource group, go to the resource group and just open it here. You see that all our resources including NAT gateway, public IP address, VM, right, and then the its own public IP address, all are sitting in the Southeast Asia. So basically that's a reason we have to create a route table in the same region. Okay, so that is a tip for you, or else you're going to have a problem in the configurations. So we're going to choose that here and then choose the Southeast Asia here and then give the name, that is a route table name is, let me call it as a RT, just like that. Okay, and the propagator route, so let it be default. I don't want to worry on that. Just click on a create. Okay, so then just click on a create, and then once the route table is been created, so you need to do one more thing, that is you go to the subnet, associate the route table to a subnet. So that is what we're going to do it right away. So while it takes a time, here you go. So it has successfully created very fastly. We go to the subnet now, and the subnet where the VM is sitting. So we went to the virtual network, then we are going to the subnet. Click on the subnet. Okay, and here you can associate the the route table. Okay, that is what I wanted to show you here. So we have a NAT gateway associated to that. Now we need to associate a NSG, that is a network security group, and then of course the route table. Okay, and then rest all option you can keep it default and then click on a save. So once you click on a save, so then what happens, this route table gets associated to that particular the subnet. Now one more thing which we have to do is the adding the routes in the route table. So click on that, and in the routes you go to the routes basically, and then click on add. So here we will call the route name as internet route, because so the when you are using a machine for GitHub action runners, you need to have the access to the internet. So that's the reason it has to have it. And then here you can give the internet IP address, that is 00 dot forward slash the 0, and then the next half is basically internet, and that's all. Click on a add route. So this is the route you have to add in the route table, which is associated to uh, the network subnet where the NAT gateway is sitting, where the your virtual machine is also sitting. And one more thing is, make sure that your outbound access on your security groups are as expected. So if I go to the network security group and we check the outbound rules or outbound security rules, it should allow to the internet. So that these are all nothing but inputs, so that your machine can talk to the GitHub Actions jobs through the NAT gateway. So that is the input here. Now we are done with the basically we are done with the configurations of all the infrastructure, that is setting the virtual machine, enabling the NAT gateway, making sure of the routes, checking the security group rules as well. So everything is done. Now what is that we have to do is we have to run these configurations in the machine and make that machine available here. To do that, we need to take the SSH of the machine, that is basically by using the public IP address. So I'm going to copy this public IP address of the machine, and then I'm going to use the putty here and try to take the SSH of the machine. Okay, so I'm going to click on this one. So this machine is accessible over a user ID and password, because when I was creating this machine, so I given this username and password. So I'm going to give that same here and try to take a SSH of the machine. Okay, so I'm going to do that right away. Once you take a SSH of the machine, you can check always, like what is the host name. So this is my host name. Okay, sorry, my command is wrong. So you can check the just run a dummy command and check that. Okay, or you can just check like a dates. All right, so we are in the um, basically we are in the Linux virtual machine. Now we need to start with the step that is mentioned in the GitHub action. So let's go back to the go back to the hosted runner page. If you see here, we were here, that is when I clicked on a settings and we went to the actions and we clicked on action runners, we chosen the run, the Linux, then it has given me these kind of commands. So what I do is, in front of you only, I'm gonna run these commands with using the local user access. So I'm not gonna use any elevated access. So that is basically a tip here. So we're gonna do a make dir and then cd to that particular dir. So here you go, right? So it has created a directory, and then we did inside a cd to that particular directory. That is what the first command is talking about. Then let's go to the next one, that is basically download the latest runner package and install it. Okay, so that is what we're going to do it now. So I'm going to copy that. That is basically this big command, and we go to the machine and try to run it. Okay, so I'm going to go back to that one, then run this particular curl command, and it should be downloaded. Okay, so remember that if you have not added a public IP address on your virtual machine, so first thing is you will have a problem to access the machine, SSH machine. Basically take the SSH of the machine and then even download the these softwares as well. That's the reason it should have the public IP address for the first time when you are setting. Once it is done, you can always try to use the then you can disassociate the public IP address. So I'm going to run the next command, that is basically this command. So here, since this is a the Red Hat Linux the version, so you might face this kind of problem here, that is saying the something, so that command is not exist in your system. So what we can do is, for that case, we need to use slightly different command which I have already tested in my locally. So what you have to do is you have to just use this one, that is SHA-256 something like that. Okay, let's try to use that command instead of this one. Okay, so I'm just gonna rerun the command with a slight modification. So that is something I would like to highlight you here. So that is a SHA-256 some hyphen. I know, so if you see that it's the same command, but the slide changes. Okay, that is what I'm gonna show you here, and then it should work. Okay, so that is what I wanted to show you, since this is a Red Hat Linux machine. And then we're gonna hit enter. So here you go, right? So it says that it has downloaded the so it has done the job that is supposed to be done through that particular Linux command. Let's go to the next command, that is basically now we have the optional, that is basically though this command was optional, but we were able to run that. The next one is extract the installer. So that is we're going to extract the installer by using the tar command. So that is what I'm going to do it now in this session only. So we are extracting this particular action runner Linux cross 64. It has done the job. Okay, now we are actually downloaded the basically the RPM file, whatever the executable file information that we needed, it got downloaded now. Now we straight away go ahead and try to run the configuration commands. So the configuration command here is basically this one, that is create the runner and start the configuration experience. Okay, that is the reason we're going to run this particular command. Okay, so since this is my GitHub action project, that is cloud cost optimize, so that's the reason the command looks like this. In your case, the command would change, so you need to run the same command from your side. So with that note, let me run this command. So I'm going to run this command in front of you here. That is so there would be a script called config.sh, and it would going to pass this particular ID, and then rest all option is as you see here. So here it says you need to register the runner by having certain input being passed here. So basically it has opened the interactive session. You just have to give the the input to the commands here. So it is asking me enter the name of the runner group to this runner. Okay, for now I'm going to keep it default. Then the enter the name of the runner, so let it be VM name by default, and the rest all here it will tag the runner with using these kind of labels, which is fine for me. And then down the line you see that runners successfully added, and rest all options. So enter the name of the folder, which will I'm going to keep it like underscore work only. And that's all. Basically once you follow this interactive the session, once you run the above command, that is /config command, right? So once you've done that, you are actually done the almost all configurations, right? So now let me go to the next command, that is the last command, which will actually run the run.sh file. So when you run this run.sh file, it basically the GitHub action software that is installed on this machine, it will try to listen the jobs that is getting initiated from the this particular GitHub repository. Okay, you see that we have given the input, that is URL input is nothing but our GitHub repository URL, and then the token that we have passed. Okay, so with using these parameters, the GitHub action software which is installed in this machine keeps listening to the jobs that is getting initiated from there. Okay, so if I run this command, let me so before I run this command, let's go to the to the GitHub, right, and then try to run it. So basically, if you see that once you are done with this one, it is telling that you can now try to run your own workflow by pointing a particular parameter called run on self-hosted. So now with this option, since we have done it, we should be able to see the runner. Okay, so here you go, right? So earlier there were no runner for me when I was showing you. So right now it shows in the offline because I have not run the command that is basically run.sh file. So this is run.sh file is basically on demand activate the GitHub action runner file, and then only the agent starts listening to the the workflows on the GitHub actions. Okay, so for now that is the reason I wanted to show you. So okay, now once we have the runners started to appear in the runners blade, now you can go back to the your repository and try to run the your workflow. So for this part of the demo, as part of the demo, I have created the GitHub action workflow like this. So if I can show you that GitHub action workflow, so I have created a GitHub action workflow which will run a basic Linux commands. But in your case, it could be different. You could be basically doing a package, you could be doing a deployment, or you could be doing any custom, the commands executing through this workflow. Okay. So in this case, as a demo, we are just running a Linux commands. So for that case, this is my workflow file as you see here. So this file gets invoked by this condition, that is when somebody pushes to the main branch, or if you are invoking manually, that is which we're gonna do it right away. In the job, you see that this job is now going to run on a self-hosted runner, which is basically labeled as self-hosted. So in the runners list, there is only one machine that is labeled with this, that is self-hosted. That's the reason immediately this workflow will run on that self-hosted runner. And then you see that these are all steps of the job which will actually does the checkout, and then it does the certain Linux command, that is basically it just does the echo and does the df something it is doing. Okay, and then does the project working directory as well. So with that said, I am done with the my GitHub action workflow definition pointing to the self-hosted the pointing to a self-hosted runner. Okay, now with that operation, so what I do is I'm gonna start the, remember that once you start the dot forward slash run a file, then only you have to run the GitHub action. So then only the GitHub action runner software listens to that particular request and processes the job. Okay, so for now, what I do is I'm going to run this particular run.sh file, and then you see that it says it is all configured, connected to the GitHub, and now it is ready to listen to the job request. Now let's initiate the job request from this one here, and I'm going to go to this particular workflow, that is run Linux command on self-hosted workflow on a branch, that is main branch. And now we should be see our job instance getting created here, and I'm going to open that, and I'm going to open further so that we see that this job gets listened by the runner and it starts to work. In the blade, you see that it has identified that the run Linux command job has been initiated and it is now processing. Whatever the processing that happens in the machine gets mirrored in this UI page of the GitHub, right? You see that it has done the checkout, it has run the Linux command. So if I can show you the output of the Linux command, here you go, right? So it has run all those commands as you see here. It has done the echo, it has done all those commands are being executed as you see here. And then show the current working directory. So the current working directory is, this is the current working directory. Basically what I mean to show you that it has run the job. Okay, and that the you can see that the job Linux run command completed with the status equal to success. So basically now you see that we have built the self-hosted GitHub runner on the Azure Linux virtual machine, that is Red Hat Linux, and then we were able to run our job via this machine. As you might be wondering, so how can I make sure that this run.sh file keep running? Okay, so every time every time I cannot come here and run that run.sh file and then I invoke the GitHub action workflow, which makes nonsense. Okay, which makes impractical. So for now what we do is you have to turn this run.sh file execution as a Linux service, and then only it will become independent and run independently. For that, I'm gonna come out of this particular loop and try to see if that works. Okay, for now what I do is I'm gonna convert this run.sh file execution into a service, and then we see that if that works. Now as you see here, there is a blog called configure the self-hosted runner application as a service. So this blog is enables you how you can convert that run.sh file as a self-hosted service, or basically runner service. Okay, so how to do that? You see that there are very straightforward steps here. That is, first one is install the service, right? And then the start the service and check the status. That's what we're gonna do it right away. Okay, so I did try to follow these steps. That is basically stuffing the self-hosted runner application, which is running in the current context. Then I try to run these commands with using the sudo access, but actually there were a lot of issues. Okay, so how did I solve that issues? And finally, I was able to run the GitHub Action Runner, service always running on the machine, and then I could see that the GitHub Action workflows are working as expected. So now let me take you to the machine. So what I did is, as I show you here, so when I was trying to start the machine by following the same step, okay, so if you follow my screen and follow the selection here, I did sudo, the install the service by running this command. It was used to go through this one. So if you see that, it was basically it was used to install it first time, right? And then when I try to run the next command, that is basically starting the service, it used to give me this kind of errors. If you see that, it used to give me the this kind of bug error. That is something related to the the issues. Okay, now you might be facing this issues as well. So then what I did is basically I myself I try to converted the access into a sudo. Basically, if you see here, earlier here I was basically, if I go above uh, here, so here I was using the here I was using the local user. Then I actually converted myself into a root users. So as you see here, so I did two things here, okay, to solve this issue. One, I changed my access to root, and then you see that I have run this command. That is basically sudo. Sudo is not required because we're already in the root. Okay, so I just run the command that is basically change mode plus execution. In the sense, I have provided the execution access to this particular run csv.sh file, which was, I think, not there earlier. Okay, so even though you see that the execution access was not there on the run svc.sh file, so which I have given. And then then we also run this command. Basically, you see that change owner equal to test vm user to, so this one I run this command. After that, yeah, of course, I run the same command multiple time. And then what I did is, so then we did this one. That is basically, if you see that, so then we did some ls of the particular command. Okay, and then later, we did the this command as well. So basically with that option, it was actually started to do that, right? That is basically, you see that we try to run the next command, that is sc status. Okay, even though I understand this is not doing anything, but then we did the sudo the set enforce equal to 0. And then we did run this command, that is basically sudo systemctl start the action, this one, right? And then I try to run the service, and here you go, the result is as expected. So basically services got automatically started, and you see that this my services started to run, as you see here, right? Now with this troubleshooting, so basically what I did is, I know I'm gonna, you can watch this video again and again so that to understand. So basically what we did is, we did couple of things. What is, these are all the commands which we executed here. And then I did these many command executions. So these are all the command. And then after that, I was able to start the service, and the service started to work as expected. Okay, now with this setup, here you go, right? So right now I'm not doing anything. And if I go to the the GitHub Actions and try to run the another workflow now, this time we are not running the run.sh script and running the the workflow, right? So we are directly running like as usual. And now we should see that the GitHub Actions should be running now. So if I create an instance of workflow and then open it, we should be able to see that this job is getting picked up there. And then it will start to run those, run this particular workflow. So if you see here, here you go, right? It has picked up the job is set. Now it is doing the checkout, and it will run the command, further command. So that is what I wanted to show you. So right, so if I open this one, basically our GitHub action workflow is now working automatically without running the run.sh script, which I was showing earlier. Okay, so what did we do is, we have now enabled the run.sh script as a service. Now it is working as expected. Okay, now even if I close the session as well, so that should be working. So if I close it, which is basically end of the configuration of my the Linux version as a the GitHub Actions. Okay, so if I can run now, it should be working as expected. So that is what I wanted to show you now. So I will run the another instance of the workflow, and we see that so that should be working, which means that we have done the configuration of a Linux machine as a a GitHub runner, the basically self-hosted runner. Now here you go, it has picked up the job, and it is doing the job as expected. Okay, now with that, so now let me try to show you the another thing, that is basically dissociating the public IP address and try to running the job, because that is what I wanted to show you. So basically, before I do that, I'm going to go on a pause and come back for that. Okay, so now you see that this is our Red Hat Linux VM for GitHub runner. So this is my Azure virtual machine, which is Red Hat Linux virtual machine. Now I dissociated the public IP address. Basically, I deleted it because it is insecure, right? I just used public IP address just to configure it. Now my machine is now kept in front of NAT gateway, right? Now with this setup, which is basically secure and suggested setup, we go to the GitHub action, and then we try to run the GitHub action. Now it should be working. So that is what I wanted to show you now. So I'm going to run the workflow again and show you that this time also the GitHub action is working as expected. So if I open this instance workflow, which is basically running as you see here, here you go, it has picked up the job, it has actually set the job, it is doing the checkout of the repository and doing the the next steps that is defined in the GitHub actions. Okay, so basically it actually worked. If you see that it has went green, right? And how it is went green, this is running on the GitHub action, the self-hosted runner, and that runner does not has any public IP address, but it is kept behind the NAT gateway. Okay, so that's the reason it is able to access the this GitHub repository, and it is doing the job actually, right? So with that note, I have shown you everything that you need to know about the running a self-hosted GitHub runner in the Azure in a Red Hat Linux virtual machine. Okay, so with that note, thank you very much for watching my videos. Kind request, please do subscribe my channel, that would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.